Hey guys, welcome back to Code with Nani channel. So today we're gonna discuss the lead code problem of the day, which is solving questions with brain power. Okay, so you are given zero based index. Okay, which is a questions 2D array, which is a questions where question of I has a two values, which is points of I and brain power of I. So the array describes the questions of an exam where you have to process the questions in order, which means we cannot solve the array. So we need to go in a sequential way. That's the intuition of this line and makes a decision whether to solve or skip this question. So solving question I will earn you a points I, but you will not be able to solve each of the next brain of I questions. If you skip question I, you can get to make the decision on the next question. So basically what they're trying in the finally we need to return the maximum points you can earn from the exam. So basically what they are saying us is, so you will be given a array which is questions which has two values, one is points and another is brainstorm of I. So if you solve, so if you solve this question, you will get a points 3 and next brainstorm value is 2. So you cannot solve the next two questions. So you can only solve from this question. Suppose if you have another x, another y, so you can choose any of these questions. Okay, but you cannot solve the next two questions. So that's the thing they are mentioning here. So and in the end, we need to return the maximum points that we can get out of these all possible ways. So you in each case you can either choose this question or you can skip those questions. Suppose if you choose not to solve this question, then you can pick this question. So if you pick this question, next three questions cannot be picked. So that's the case. So if you observe carefully, this is kind of a coin chain problem where you can pick this coin and or you can skip this coin, right? So in finally you need to make that target. So similarly here, either you pick this question or you cannot pick this question. So if you pick this question, you can skip the brainstorm of ith indexes from the current index. If you didn't pick this index, you can directly go to the next index. So that's the intuition behind this problem. So for this example, suppose one case you pick this question, let's say, and you cannot pick this question, you cannot pick this question, and now the target is, now we get a point is 3 plus, and finally you pick this index as well, 3 plus 2 5. Okay, cool. So right now we got a point as 5. Suppose you didn't pick this question and you started to thinking to pick this question. In that case, you get a 4 plus, and you need to leave three indexes. 1, 2, 3. There is no more. So you will probably get 0 points. So 4. Or else you pick this question and you cannot pick this question. So with that case as well, you get a 4 points. And in the end, you only pick this question and you left all these questions. So you get a 2 points. So out of all these value, what is the maximum? 5. So that you need to return. So you can ask me, so how you get to know this? This is a DP question or recursion question. So how you can guess the intuition behind? So if you carefully observe this pattern, so you need to check all the possible ways, right? So suppose maybe you can pick this value. Suppose I'll give an example. In this, you'll get clarity about in the second example. So here Here, if you pick this question, you have a possibility you will get a points as 1 plus. So you cannot pick the next index. Okay, let's leave it. But you can pick this one, or you can pick this one, or you can pick this one, right? So what we need to return? We need to return the maximum value out of it, right? So if you pick 3, that will be 1 plus 3, which is 4. But if you pick 4, it will be a greater value than the previous value, right? 1 plus 4, 5. What if you pick 5? Now 1 plus 5. So you need to check for each index, you need to check all the possible ways. There might be another index which can lead to the maximum value. So if you think carefully, then will strike you that we need to use recursion, which will check out all the possible ways. So recursion will give you to power, like we will have a skip or we choose an index. For that case we need two recursion calls, which is 2 power n time complexity for the recursion case. As n is 10 power 5, 2 power 10 power 5, which is a huge value, definitely gives you a TLA. Then what comes to our mind? We need to optimize this solution. So how do you optimize? We use dynamic programming. So we use top down or bottom approach to optimize this time complexity, which means like we are optimizing um, the states which are repeating more than once, or like which are the states which are repeating. So we'll use DP array to retrieve the value instead of recomputing the same values. Okay, so that's where the intuition comes from. So first you need to understand how we are approaching the solution. As we are approaching the solution, we need to figure out all the possible ways. So we came to a certain stage which we need to use recursion. So from recursion we could, if you carefully observe our constraints, through recursion it is not possible. So then we come to a state dynamic programming. So that's how you need to build the intuition to solve the problems. Okay, and now you'll ask me how we can use recursion to solve this problem. Okay, so now we'll write a function. Suppose now we'll write a function which is a helper function. Okay, that will return the answer for this recursion call. So what are the things that we require? We need to track of the index, right? So uh, for each element where we need to track the current index. So from the current index to, we are skipping to the next index. Like if you don't take that element, we'll shift to the next index. Or you can, if you pick the current element, we need to go to a next index, which is the brainstorm of I, right? So for that sake, we need a index to track the elements and the questions array. Okay. So what are the basic principles in a recursion? We'll be having a base case, first base case, then recursion calls, then the return statements. Okay, first let's not consider the base case because we'll come to that part in a later point of time. So now we'll check the calls. Suppose we need to return the integers, right? Integer or long whatever it be, I'm just writing a pseudo functions. Suppose we are skipping the current element. What you say? If you are skipping this, you are not considering the present element, which means 0 will be added, right? If you are not considering the current element. Okay, then we need to call the recursion. You need to call the same function by incrementing the value. Because why? Because if you are not considering the present element, then you can switch to the next element, right? So that's what we're doing. Okay, what if it is a don't skip value, which means if you, or you can say skip and take, that will be a good convention. So if you are taking the present element, means you will, what you will get, questions of the current index. So this is the current index, what the points that you get. So if you are picking this current questions, zeroth index is will be the points. Okay, plus, so if you pick this current index, then what the next recursion call will be helper of. You cannot pick the next index. Why? Because so if you pick the current index, so there will be a first value, second value. This will be the score that you get, and this will be the indexes that you need to skip if you pick the current index, right? This is the brainstorm. So that will be the index plus brainstorms plus 1. So until the brainstorm you cannot take pick the index. Plus 1 will give you the correct index, right? Suppose right now the current index is 3 and we have a brainstorm as 2. So 3 plus 2. which is 5. So until 5 we cannot pick the index. So if you are calling 5 plus 1, which means from 6 index you can pick. So that's what you are doing. Brainstorm plus 1. Okay. And the questions. So here, what is the brainstorm? Brainstorm will be questions of index of 1. As they are saying, it is a 2D array, which is questions of index will use the element in that particular array, and zeroth element in that particular element will be the score, and first index will be the brainstorm. And in the end, what you need to return? So if you pick the current index, you got the value as 3. And if you don't pick the element and you keep on recursion in some other tree, I mean, which means in some other place, you get a maximum value. So what we'll return? We'll just return max value, right? So same thing, max of skip comma take, whatever will be the maximum value that will be returned. Okay. So this is the basic recursion calls and the return statement. So what will be the base case? So what if the current index is greater than this questions array? So then you won't get any question to solve, right? In that case, we just return 0. So that will be the base case. If index is greater than or equal to questions of size, which is greater than the particular vector size, then directly return 0. So this is the basic recursion. So you can use this function. Suppose if you want to optimize, so I'll tell you a trick. Okay, as what is the variable that is changing here? Questions is a static because it's not changing. It's a given by given by an input, given as an input. Okay, only thing is changing is index. So we only have one value. So you can directly pick dp of size n, which is the size of these questions. Why I'm choosing a I mean 1D vector, because we only have one variable that is changing. Okay. So initialize with the total dp with -1, so we can track whether it's already been visited or not. So whenever you are entering into a new stage, we will write if dp of that particular index not equal to -1, which means if it is that particular index is not equal to -1, which means it is previously been computed, right? In that case, directly return dp of index. Okay, similar thing. If it is been visited previously, directly return that value. In the end, if it is not been visited, we got to skip and take values, and finally update that value. dp of I equal to max of this. These things will be updated on that particular index of the dp, index of I. So just a simple little tweak in the recursion code that will give you the optimization based on that dynamic programming. So you know how to use the dp, right? If two values are changing, we need to use a 2d dp, or if only one value is changing, just we can use a single dp array to solve. And I'll give you an example how our recursion works, so I'll get better clarity around the question. So I'll take this example 1122. So I'll draw the recursion tree and all, so you'll get clear picture. I think right now you are aware of the how the recursion calls are being made and how I wrote the recursion. Still, if you have a little more confusion how the recursion tree works and how this being called some next recursion tree, I'll write the recursion tree, then you'll get clear picture around the question. Now the example is 1122334455, right? So now I'm calling a function which is function of which is index comma that questions array. I'm just writing a pseudocode. If index greater than or equal to q dot size, just returning 0. Okay, 0, or else into take case will be, means skip case will be 0 plus f of index plus 1. If take case will be q of index of 0 plus f of index plus q of index y if 1, it is the brainstorm value plus 1 comma q, return max of st comma t. So this is the basic recursion call. So now when you are calling this function, you are giving a index as a 0th value, so it will call for f of 0 comma the q is will be the q. Okay, and now as you can see, there might be a case, two cases, whether you pick one value. So if you take this case, you either you can skip the case or you can take the case. Suppose we are taking the case, then it will call for f plus, and you need to skip next index, right? Like this index will be skipped, and f of 3 comma q. Okay, and if you do not pick the index, in that case 0 plus the next case, it will go for next case. Okay, I'm just rubbing the code. So just use these cases and you'll get to know how this been created. Just for the reference, I wrote it and now I'm clearing, or else you couldn't be visible, whatever that will be blocked my video. So in this way you will get visible around. Okay, so now f of 3 means you're here. Okay, either you pick it or you don't pick it. Okay, f of if you pick it, that will be, if you pick 3, so that will be 3 plus f of, you have a 3, so you cannot pick this, you cannot pick this, that will be 3 plus 3, that will be 6. Okay, if you do not pick it, we'll still have an opportunity, so it will be 0 plus f of 4. Okay, so as you see, why we are writing base case, now the index is 6, we only have a 5 places, so as this reach out of our bounds, so in this case, in the base case, we return 0, so here it is 3. So this recursion tree base case, this recursion tree, the left part ends with the 3. Now we check for right. So if we didn't pick 3 and we reach to a 4, again we have a two condition, either we pick 4, if we pick 4, 4 plus f of 9, which is out of our bounds, will get 0, so this is to 4, and if we didn't pick 4, in that case we have a 5, f of 0 plus f of 5. So f of 5 will definitely returns 5, because we and the current index will reach to 10, because 5 plus 5 10, and it is out of bounds. So let's say 5 plus f of 10, we don't have f of 10, so directly it returns 5. Out of these two, what is the maximum value? 5. So maximum value will be returned, right? This will be the 5. So out of these two, what will be the maximum? So that return statement will execute after the recursion calls. Okay, we are backtracking to the previous stage. Out of this, which is the maximum? 5 is the maximum, so this will return 5. So what is the value? 1 plus 5, this is the 6. So left sub tree returns the 6 value for that f of 0 comma 2. I'm not drawing the all the recursion flows, because that will take too much time. I'm just drawing it as a reference, so you'll get understand. Okay, now now for 2, we'll be having a two chances, either we pick 2, if we pick 2 we'll be having a case like, either we can go to 1 2, or we can only go to the 5. If you don't pick 2, still be having 0 plus f of 3. So I'm just writing this case. F of 5 will give you 5 plus and f of 10, which is out of our bound, so it will return 0. This is 5. 2 plus 5, this will be the 7. What if you don't pick 2? We'll take 3. You can take 3. You can take 4. Or else I don't write it here. So if you check all the possible ways like this in this recursion as well, you only get the 7 as the maximum value. So out in from this right subtree, if you want to try, you can try, but I don't want to take too much time for this video, so I'm just taking the answer case. So from this taking a two case, that will give you the maximum value is 7. If you take some other recursion calls as well, that doesn't give you the maximum value. Okay, this will give the maximum. What is the maximum value out of these two? This is the take case, this is the skip case. So if you skip the first index, then you're getting maximum value is 7. If you take the case of first case, you will get only the 6 as the maximum. The 7 is the maximum, so that is the answer. That's how you this recursion tree goes. Okay, and let's just show you my code and you'll get clarity on my question. So I'm just zooming in for you guys. So as you can see what I'm doing, as they are said, it will be the long value. So in order to get rid of that outbound conditions which outflow errors, so I'm just putting everything as a long, even in initializing the dp as a long integer. I tried using int, but the 54th case, which is the last case, is missing, because in the dp values also, if you are pushing the int values, which if it is a long value, it is out of our bound, so we cannot do that. So initializing vector or dp with a same as the array vector size with a -1, so we can track of it. Just return the helper function, which is the recursion function. What we are doing in the recursion function, if the current index is base, this is base case greater than the array size, just return 0, which is out of our bounds. Skip case, which means you are skipping the current index. In that case, it is a 0 plus, because we don't have anything to solve to get the points, right? So 0 plus recursion of index plus 1, we can directly go to the next index. If you are not skipping this current index, so current index score plus recursion call, so index plus this is the brainstorm plus 1 will be the next eligible index. In the end, just return max of skip plus don't skip. But as we are storing in the dp array, if dp array of that particular index is not -1, which is not, if it is not -1, it is previously been visited. In that case, directly return that dp value. In the end, if it is not been visited at, store that value in that dp index equal to max of skip dot. Just submit the code. All are submitted, and that's it for today video, guys. So if you like my explanation, do subscribe to my channel, hit that bell icon so you never miss any notification from my channel. And if you have any queries regarding my explanation or regarding my code, do put it in the comment section, so I'll help you out, guys. And that's it for today video, guys. Thank you, tata, bye bye, see you tomorrow with a great content. Bye bye.